Welcome viewers to my YouTube channel Maths Maestro. In this video, we are going to discuss problem set number 2.1 from Erwin Kreyszig. I will not be able to take all the problems because then the video will become very long. So I am going to take few questions from reduction of order 3 to 10, which is shown here in this exercise number. We are going to touch question number 3, 4, 5, and 8, 9, and 10. Problem number 6 and 7 we will not cover in this video because this is with reduction of method order, this is not working out. We need to actually use some other method to solve this. What I'll do, I'll take maybe another these questions in another video. Okay, and now let us go to the screen mode in order to solve these problems. And before I go ahead, I would like to request all of you to kindly subscribe to my channel. Okay, and if you like the video, give me a thumbs up and share this video with your friend. Thanks a lot for joining in. So this is the third question which is available, okay, in the book, and this is not at all difficult, it's quite easy. Let us assume y prime is equal to u, therefore y double prime will become actually u prime, or this can be expressed as dy oblique dx is equal to u and d2y oblique dx square is equal to u double prime. We have to substitute them here and we find this will be actually u prime, this will be u is equal to 0, this will give us u prime minus u, or u prime oblique u is equal to minus 1. Now, the moment we integrate this, as I have discussed in earlier videos also, if you look at this, the numerator is actually a first derivative of the denominator. So the moment we integrate, actually we will get on the left hand side as natural log of u, and on the right side, since we assume the variable x, we will actually get minus x plus a constant of integration c. We can also write the constant after applying this anti-log here. This will give us what? This will give us u is equal to e to the power minus x plus I'll multiply with the constant c1, and here we have u is equal to dy prime, which is nothing but dy oblique dx, and we will have c1. This is a simple variable separable question, so we will separate the variables c1 and applying integration on both sides. Here also it will be there. We will have y is equal to minus of e to the power minus x c1 plus c2, a constant, okay. Therefore our answer will be y is equal to minus of e to the power minus c1 plus a constant c2. This is the answer. So we have come to the question number 4. Question number 4 is appearing on your screen. This is also kind of not very difficult. Let us assume y prime is equal to u, and we will have 2x, y double prime is u prime, and 3u. We will separate the variable here, or I will choose to write u prime as du oblique dx. So we have 2x du oblique dx here, plus we have 3u. Now we have to separate the variable, and we get here, first of all, I'll divide the entire expression with u and then multiply with dx. So we will have 2 du oblique u is equal to, on the right hand side we will have dx, and this x will come here, this will become x, and this 3 will remain as it is. Again apply integration on both the sides. we get 2 ln u is equal to 3 ln x plus a constant of integration. I take ln c1, and this will be nothing but ln u square is equal to ln x cube plus ln c1, and this will give us nothing but ln u square is equal to ln c1 multiplied by x cube, and applying antilog on both the sides, we will have u square is equal to c1x cube, or this will be u and this will be under the root of c1x cube. Okay, we can write this as u is equal to, I will take a different constant in place of c1. Maybe I can write simply c2 in place of a square root c1, and x to the power 3 oblique 2. Since we have assumed what, u prime as equal to u, or dy oblique dx is equal to u, we can replace here. It will come dy oblique dx is equal to c2 x to the power 3 oblique 2, and this will give us nothing but dy is equal to c2 x to the power 3 oblique 2 dx. Now apply integration here and here. We will have y is equal to c2 x to the power 3 oblique 2 plus 1 divided by 3 plus 2 oblique 1 as per the rule, plus another constant c3. This will give y is equal to 2 oblique 5 c2 plus, no, pardon me, this will be x to the power 5 oblique 2 plus a constant c3. This entire thing can also be written as just c2 x to the power 5 oblique 2 plus c3. In the answer of Kreyszig, maybe answer will be given as y is equal to c1 x to the power 5 oblique 2 plus c2. All of these are correct actually. So let us move to the next question. Question number 5. Question number 5 is here. This is appearing on your screen now. Again, if we do an assumption of y prime is equal to u, we will get, by differentiating both sides, we will get y double prime is equal to u prime. Y is equal to, or I think we can use a little different method in this. What I'll do is I'll divide the entire expression with y prime first. So we will have y double prime divided by y prime. This is 3y prime. And then I'll divide the entire expression with y. This will give me y double prime divided by y prime is equal to 3 of y prime is equal to y. Now friends, we have learned in basic calculus that if x is there in the denominator and its first derivative is there on the numerator, and we apply integration sign here, we will get natural log of the item which is there in the denominator, x, plus a constant c. This is the rule what we says. Now if we assume y prime as x, then we have y double prime, which is nothing but the first derivative of y prime. Okay, this is nothing but the first derivative of y prime. If we apply integration here, we will get what? We will get ln of y prime. Similarly, if we apply integration here, the one in the numerator is first derivative of the one which is in the denominator, which means this will be ln of y. Okay, I will add a constant of integration ln c. This will give us what? This will give us ln y prime is equal to ln y cube plus ln c. This will be logarithm of cy cube, and applying anti-log we will simply get y prime is equal to cy cube. Okay, let us take it upward. dy oblique dx, which is nothing but y prime, is equal to cy cube. Now let us take this much and do a variable separable in this. So we will have dy oblique y cube is equal to dx, and this will be nothing but y to the power. If we take this in the denominator, from denominator to numerator, the sign on the 3 will reverse and it will become negative. This will become y to the power minus 3 dy is equal to dx. Okay, apply integration dx. This will give y to the power minus 3 plus 1 divided by minus 3 plus 1 here is equal to x. This was already c. C has to be there, so actually this will become cx plus another constant c1. This will be minus of half y minus of 2 is equal to cx plus c1. I'll multiply entire expression with minus 2, and we will get y to the power minus 2 is equal to minus 2 cx plus c1 here. And I will assume a different constant by merging minus 2 into this. Let those new constant be c2 and c3. So we will have actually nothing but here c3 c2 x plus c3, and y square will be 1 oblique c2 oblique c3, and this will give us nothing but c2 x plus c3 to the power minus half. I think, friends, this is the answer. Right? So let us move to the next question now. Okay, we have this question, which is question number 8. We are taking question number 8 straightforward, skipping 2 questions in between, that is question number 6 and 7. And here also an assumption will do the work. Let us assume y prime is equal to u. Therefore, we will have y double prime is equal to u prime, and we will have to do the substitution here. So we will have y prime here and 1 plus u square here. Okay. This we can assume dy oblique dx is equal to u, and d2y oblique dx2 is equal to du oblique dx is equal to u prime, and I will write du oblique dx here plus 1 plus u square. Take this in the denominator and bring this in the numerator this side. We will have du oblique 1 oblique u square is equal to dx. Now apply integration on both sides. We will have here tan inverse of u is equal to x. I will put constants afterwards in this. Okay, and this will give us nothing but u is equal to tan x. So in place of u, you can use this one, dy oblique dx is equal to u is equal to tan x, or dy delta y is equal to tan x of delta x. Again, application of integration on both sides. This will become y, this will become sin x cos x dx, and if we assume cos x is equal to t minus sin x is equal to minus dt oblique t is equal to minus of ln t plus a constant of integration c1. Y is equal to ln of 1 oblique t plus c is equal to ln of t we assumed as a cos theta, so we will have 1 cos theta here plus c. In place of c, let us put ln c1 as a constant. Therefore, we will get y is equal to ln of 1 c1 oblique cos x. This will be the answer. In place of cos x, you can write secant also. That will also do. But this is going to be the answer of problem number 8. Let us go to question number 9 now. So we have come to question number 9. Okay, and this is a truly reduction of order question. It's very nice. What we need to do is we will assume the second. We have to find the second answer for this. We will assume the second answer as a multiple of first answer, which is u is equal to y1 or u is equal to x cube. Now, in order to substitute u2 into this, we need to find out the first prime and second prime of this. So we will have first prime of u2 is equal to delta of u1 y1. This will give u1 y1 prime plus u prime y1 is equal to u, this prime will become 3x square plus u prime and x, y1 prime, simply y1, so not y1, simply y1, which is actually x cube. So we have this one as 3ux square plus u prime x. Now double differentiate it, y2 double differentiation. We will have to apply the differentiation on y2 one single prime or differentiation of 3ux square plus u prime x cube. This will give us 3u prime x square plus 3 is to 2 is to ux. Here it will give u double prime x cube plus 3 u double prime x square. 3 u prime x square plus 6ux plus, this will be single prime here, sorry. 3 u prime x square, this will also become 6u prime x square plus 6ux. I'll choose a different color for minus 5xy. Minus 5xy will be minus 5xy2 prime is equal to minus of 5x. u2 prime is 3ux square plus u prime x cube is equal to minus of 15x cube minus of 5u prime x to the power 4 plus 9y y2. Now we have to add all of them. So we have 6u prime x to the power 4 plus 6u x to the power cube plus u prime x to the power 5 minus of 15 u x to the power cube minus of 5 u prime x to the power 4 plus 9 u x cube. Now we have this 9 plus 6, this is actually 15. This will go off with, and this is 6, this is 5, and here is 0. So we will have u double prime x to the power 5 plus 6 minus 5 is just 1, so u prime is equal to x to the power 4 is equal to 0, or we will have u double prime x plus u prime is equal to 0. So friends, you can just note in this particular solution, one u has got eliminated. Means we have actually been able to reduce the order of the entire equation by 1. and we have only u double prime and u prime to solve. Now let us assume u prime is equal to w, or I'll take p. This will give u double prime as p prime, and we will have p prime x plus p is equal to 0, and this will give us p prime oblique p is equal to dx minus x. Put the application of integration on both the sides to get natural logarithm of p is equal to minus of natural logarithm of x, or write it as natural logarithm of p is equal to 1 oblique x. Apply anti-log to get p is equal to 1 oblique x. I am actually leaving constant of integration right now. We can put it in that in the afterwards as well. And then we have here p is equal to u prime, which is nothing but this one. So we will have du is equal to dx oblique x. Apply integration to get actually u is equal to ln fx plus ln of c1. Right, so we got u here, and we have to find what is the second solution. Second solution is nothing but y2 is equal to u dot y1, which is x cube. Our second solution for this will be actually y2 is equal to x cube of ln x plus a constant of integration c2 if you want to put it. But usually in case of reduction of order, when there are two distinct solutions, this constant of integration is not required, since we have our answer known. So since our first answer was known, the second answer will be y2 is equal to x cube ln x only, and this is the final answer. So let us go to the last question. So friends, we have come to the last question of this particular section, which is reduction of order. This is also quite simple in my view, not going to be very difficult. The question just looks a little complex. What we can do is we can multiply, we can divide the entire expression with y prime. We will get y double prime divided by y prime plus 1 of 1 oblique y prime square divided by y prime will be just y prime equal to 0. This will give y double prime plus y prime plus y prime oblique y is equal to 0. Now apply integration on both sides. We get natural logarithm of y prime here, plus y prime will become just y, and this will become natural logarithm of y is equal to, this will become a constant c, because the moment we apply integration on a 0, it will give us a constant. Now we can bring both the logarithm item together, and y prime plus ln y plus y is equal to c1, and we know with the logarithmic rules that this can be multiplied in one log, and we can write y prime, and this can be written as c1 minus y. Now we will have to make use of anti-log. So we get y prime on the left hand side, and here on the e to the power we get c1 minus y. This is nothing but e to the power c1 divided by e to the power y. This we can assume as a different constant. Let it be c2. Therefore, we have y prime is equal to c2 oblique e to the power y. And by doing a variable separable, we may get here y dy oblique dx is equal to c2 oblique e to the power y, and this can be written as y e to the power y dy c2 dx. Now application of integration on both the sides, and what will we get? Here we need to use integration by parts. Okay, so when you apply integration by parts, your answer will be y e to the power y minus e to the power y, and this will be nothing but c2x plus another constant c3. Okay, and this will be y minus 1 e to the power y c2x plus c3. This is the final answer, friends, for this. Therefore, for this particular session we are done. Now I will solve the next set of questions in another video. Will be coming pretty shortly after this. And once again, before leaving, may I request you to kindly subscribe to my channel, and if you like the way I solved the questions, kindly give me a thumbs up and share the video with your friends. Thanks a lot for joining. Bye.